Hello everyone, I'm back. Alright, let's do this. Toplets matrix, whatever that is. N by n matrix return true if the matrix is a toplet, otherwise return false. Matrix is toplets if every diagonal from top left to bottom right has the same elements. Oh, this is true. Wow. This is not. Interesting. What if matrix is stored on disk and the memory is limited so that you can only load at most one row of the matrix into the memory at once? What if matrix is so large you can only load up a partial row into the matrix at once? Oh, look at this follow-up question. If you only go row 1, you can see this is shifting, right? So to make everything the same, then this one shall be shifted to the right. So what we can say is we load the first one, right? Wait, hold a second. You load the first one. But how do I know they're the same? If I can only load one row at a time. Can I save this? You at least need to give me a chance to save, right? Like after one row, I don't care about the last one, I just need to remember this 3. So in the second row load in, we just compare this and this. If they're the same, I load this, I save this. I'm going to solve this way. So every time we load a row, and then we don't have to load, right? We memorize this 3, and then when the next one load, we go from the front. No, what would be the good way to say about this? We set this aside, right? And then we compare. If it's the same, push it in. Same, push it in. Same, push it in. No, same, then we don't push it in. If it's the last one, we don't push it in. And then this is staying in the memory. For the new one, set out. Compare. Yeah, so that's how I'm going to do it. We have 31st, right? Yeah, we have 31st. So I'm going to try this so it's not partial. I mean, if you think about partial, it's still possible. I will load 2, right? Oh, then how about this one? Huh. Then we just compare partial. If we can only load 2, we compare this, like we do 2 at a time, and then we load these 2, right? Load 2, 3, and then we load this, Yeah, even if it's a partial, I think it's still possible. We just do this and this, right? We just have to load it multiple times. Like however many we can do, we do that, and once we're done, we just skip to the last one, and then we do this one again. Do it another time. I think that's possible, but for us, for the current purpose, I want to use that method. Oh, I think I did the wrong thing. Yeah, I think we can just use the just load the first one. Okay, we'll load the first. We don't even. Oh, do we even need to? Yeah, we imagine we can only load one row at a time. Okay, so we need to load the first. So the row, we load it with some matrix 0, first row, but we're gonna load into this, okay? And then say for I in range 1 to len matrix, right? And then we just load it, and we say temp equals you're loading it. Man, I don't like this. It only allows you to load the one row. I already have one row, so I cannot even access it. Oh, I don't have to. I'll read it directly from the disk. Okay? I read it directly from the disk. So temp is going to be, this is me reading directly from the disk. That's what I'm doing. I read it from the disk, right? And then I say for j in range, we always go from 1, right? And we have to go 1 to the end. Yeah, might as well get m and out, right? So this way, we are only loading one row into the memory. The rest we can read directly from the thing, right? So what we do is we say if matrix, right, ij is equal to the row. This is the one we load into memory, and we just say if it's equal to row. I don't even need this, right? We don't even need this. Just equal to row. Row what? J minus 1. Right? If it's not equal to, then we'll return false. If it's equal to, so we go through all of them, then we say row equal to matrix I, we load into memory. Then we go, and now we return true. Yeah, so basically for everyone, I start from here, and I compare this to the row, and then we equal, good, and then we replace row with this, right? So this is memory space is lower. Partial, I'm too lazy to even think about partial. You want some edge case? Yeah, sure, edge case. Yeah, I think this one should be right. Okay. But is it optimal? I'm not sure. Technically, I think this only requires loading one row into memory at a time. On condition that we can query matrix content directly from disk. So what are the smart solutions to this? Group by category, yeah, that's true. In the middle is all the same, and then in the front is going to be, yeah, for each one we're just gonna go down. Yeah, get the value out. Top left neighbor. Yeah, we only need to compare top. So, oh, that's a good one. That's a good one. For the follow-up. Read the first row. Free up one space. Oh, I see what you do in there. You put it at the back. Yeah, the first one. Interesting. Yeah, because the back we don't need. We pop this, push in, compare, push in. Oh, we can't compare. We need to push in. Yeah, we push in, and then we compare. We compare, and after compare, we just pop and push in. Okay, once we're done, we pop. Oh. So that's the trick. We load this in, right? And yeah, so this basically it's similar, but I have this, but it will be easier to just pop this, right? Push this in, compare, 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 right? Once we're done, I went and pop this again. Now we pop this, push this to the front, and then compare, compare, compare. Right now, become this row become this, and now I pop this, push this. So it's the same idea, but okay, I'm gonna write. Let's write two more. Traditional solution. Compare to top left neighbor. Turn or I in range, J in range, right? And then if the I is 0 or J is 0 or matrix Ij is equal to matrix I minus 1, J minus 1. That'll be really fun. Good solution. and 3. Okay, this is from the discussion. It's on the response in the official solution. Okay, so it's the same idea. It's the same idea as solution 1, but does it in a nicer way. So I say a row shall be a deck. Okay. We actually put the first one into it. All right. And then for I in range 1 to m, for each one, row.pop. Right? That's the previous row's last element doesn't need to be compared. And then when I row dot append left matrix I0 current row's first element doesn't need to be compared. Right, and then we have a j in range 1 to n if, how can I just say, if all, when they return false. This can be matrix ij, okay, so we can read equal to row j. This is this, right? Otherwise, we'll go for the next one, and then we'll return true. Nice. Wait, is a pen left? No. Index out of range. That is interesting. So which one? First one. How? Yeah, we pop and then we append. Hmm. Five. What? What is this? Five, 1, 2, 3. Ooh. Wait, hold on. 1, 2, 3, 4. Pop it, push 5 into it. Right? And then we compare. And then we'll pop 3. Right, pop 3. Push 9 into it. That's... yeah. Matrix ij equals row j. Oh, if all is the same, because if any is if any is not the same, right? That's the one. Well, that's about the same. All right, so we've done this. Let's keep going. Max number of vowels. Turn the max number of vowels letters in any substring of S with length of K. Substring II contains 3. 3. That's 2. It's isn't this just a sliding window? Yeah, just sliding window would do. Okay. Unless I'm missing something. But so far I see a sliding window. Oh. Alright. Actually, we don't have to. We're just gonna be it's fine. I equals 0. So j in range, j will always go down to the end. Minus. Alright, we say if j minus I plus 1 is now we always add, and we just say vowels A, E, I, O, U, right? And we say res equals current equals this. Nah, current is 0. Come on. Current is 0. Right, I'm going to say current plus equal to Sj in vowels. And then the whole thing, int this, right? And then we add it, and then we just say if j minus I plus 1 is larger than k, right? If it's larger than k, then current minus equal to si in vowels, right? And then I plus equal 1. Otherwise, we don't do it. And then we say res equals maximum res in the current. And then we'll return res. Okay, let's try this. This shall be 3. This shall be 2. And this shall be 3. No, this is 2. Okay. Looks good. And I don't want to random generate. I think I can just do K, I don't know. I just smash, 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 smash. And then let's do 19 for fun. Yeah, looks right. We can also do, let's say, ABC, AB, and then 2. To get a 0. Usually you should test 0 as well. Yeah, let's test a 0. Okay, try this. Yep, sliding window it is. Basic sliding window. Oh. Sliding window. Oh, I can equal to 0. Yeah, we don't have to use. No, there we go. Okay. No Ghana to do another difficult one today. We'll leave as is, but we actually have time. Let's do another one. Display table of food orders in a restaurant. Given an array of orders, which represents the order that customers have done in the restaurant. One specific order's I is customer name, table name of food item. The custom name is the name of customer, table sitting on, and food item is the order. Return the restaurant's display table. Table whose just rearrange the data. Alright, that's basically what my research is. 90% of it. That's probably exaggeration, but 60% is rearranging data to make it better, either to run scikit-learn or to display. I'm telling you, man, scikit-learn is very powerful. And in my opinion, if you are not specifically dealing with problems in the domain of deep learning, let's say image recognition, image related, speech related, all right, none of those, I suspect. I mean, also those time series or what's that called? Oh man, I took the class and I already forgot. Yeah, but there are certain things you cannot do. But the majority of the analysis, I think scikit-learn is more than enough. More than enough. All right. Anyway, what we'll do, we're gonna get the display table. Rows denotes how many of each food item. Bless you. Each table ordered. The first column is the table number. The remaining columns correspond to each food item in alphabetical order. And the first row should be a header whose first column is table, followed by the name of the food items. Customer names are not part of this. Additionally, the rows should be sorted in numerically increasing order. Wait, hold on. We also have to sort based on the... Wait, what? Row, how many each food items for each table? Okay. So food item has to be alphabetical order, right? And then we have this, then we have the number of orders, the customer names, and not the rows should be sorted in numerically increasing order. What does that mean, the rows sorted in numerically increasing order? I think it means we'll have 0 beef, 2 burritos. I mean, this is sorting. This is sorted, right? And how do you sort rows in numerically increasing? What do you mean? Is it the tables? You have to sort of the tables. I think that's what it means. You sort the tables, right? Otherwise, these are the numbers here is observations. You can't do anything about it. The only thing you can do to make sure the table is deterministic is you sort this for sure, and you have to sort the table values. We'll see if yeah, I think that's about it. Okay, so oh, you gotta be kidding me. Not even integers. Holy crap. Oh, these are not integers either. Damn. Okay, we go through this, use a counter, so we can count all of these. And, oh, counter. Counter is actually 2. That's awesome. Counter is a little bit, so it has to be table, right? So within table is another counter. Okay, so it's a dictionary, and the dictionary will be a counter. So I comment this goes to the out layer, outside dictionary. This goes to the inside counter. Okay, yeah, it's not hard. Yeah, people don't like this. This is a what should I put it? I mean, yeah, this problem. It keeps you sharp if you haven't touched this for a while, but it's not like those go in a grid, go 4 directions type of problem. I'll do counter, I'll do a default dict. Yeah, I'll be fancy. And then I say rest dict equals to default. I'm actually not sure. Let's try this. I think it will work. Okay, for I don't even need name. Table, call it tab. I call it T and food, right? F in orders. We do rest dict T F plus equal 1. Once we're done, we are going to sort. Okay, so so rest equals this. Holy moly. We also need all the food items. Dang. So we need food. Food. That's going to be a set. Let's go food dot add f. Okay. Yeah, it'll be hard to get all of them. And then you can say, let's say food equals sorted food. Okay. We sort the food, and then tables, table equals sorted rest dict. Okay, now we have all those. Then we can say for T in tables, for T in table, right? Then for F in food, then what do we do? For F in food, then rest dict T F is going to be this. And also, oh shoot, I have the rest shall equal to food. Table plus food, right? And then cannot do this way, so just for T in table, right? For this in this, the rest dot append T. Yeah, append T. And then rest dot append. No, rest, not rest dot append. Rest minus 1 dot append. Dot append, dot append. Rest dict T and F. Then we're gonna return rest. Okay. Just take a look, see how this one goes. And that's how I usually do, the research. It's basically the same thing. Holy crap! They have to be in STL. This is going to be how I do research as well. You write some code in Jupyter Notebook, and then afterwards you run it, and you check if it's correct. If it's correct, you move on. If it's not, you debug. That's basically how it is. Been doing this for 3 years. They work all the time. But using Jupyter Notebook requires some planning ahead of time because it's everything that you do in one notebook. It's in the global space, so you can always call them. And if you are not diligent about how you name your variables, sometimes it can cause great trouble. All right, we have issue with the first one. Table, beef, ceviche, fried chicken. That's all good. Did I not sort? I did. Oh, you gotta be kidding me. Dude, you gotta be kidding me. This is not good. All right, we have to go int here. I see why people hate it. Yeah, I understand. So we have to swap this back to str. Yeah, it's kind of silly, huh? This question's kind of silly. Yeah, no, not really purpose, right? It's just that's a problem. Very straightforward. Data wrangling. Actually, this probably is under data. Maybe it's a data science problem. Yeah, it could be a data science problem. Now the tricky part is everything in orders is string. Right? But we have to sort. Is this in a contest? Hey, wow, this is in a contest. But we have to sort sort tables by using the integer version. Also, the count in the returned table is string. That's basically it. I'll call it ON. Okay, I think that's it. That's all the journey. Yeah. Oh, look at that. This is interesting. You see that? That's actually quite smart. Key equals int. Nice. Upvote it just for this. And this is fine. Very interesting. All right, so yeah, let's use that. Tables. Now we don't have to do. We just use this. Update. So a clever way that uses the key to sort tables by integer. So food, yeah, you have to sort food. Oh, we can actually put it here. All right, I put it here. Tables we don't have to sort. So we can say sorted table key equals int. My God, this is smart. And yeah, then we don't have this tr yet. It's just gonna be this and plus.
Close the window.
No, I did not. I'll close the window. Then we do this, right? Just say for f in food right now. in like 3 minutes. And then we just run it. Oh my god, come on. Table is not defined, sorry. Restdict. How? What is wrong? 3, 5, 10. 3, 5, 10. The count. Ew, that was ugly. That was ugly. That was ugly. 0, right? And 1 to the end. Okay? Huh? Yeah, this is very smart move. By that's okay, submit this and we'll call it a day. Look at that. Save time. Save time. Okay, that's it. All right, I'll see you guys tomorrow. Adios.